In this video, we're going to learn one final factoring technique to help us solve equations. And that factoring technique is called difference of squares. So remember, there's many techniques to convert an equation from standard form to factored form so that we can solve it. We can try common factoring, decomposition, sum and product, which is our shortcut. And our last one we're going to learn is difference of squares. Before we learn how to factor by difference of squares, let's try this warm up. So what we have here are two binomials, and it looks like they have opposite factors. This is a x minus 3, this is x plus 3, and then here we have 3 plus 2x, and then we have 3 minus 2x. They're not really opposites because if this is positive x, positive 3, this should be negative x, negative 3. But what we actually call these are conjugates. So these are conjugates of each other, and these are as well, where the sign in the middle of the two terms is just changes. So let's multiply these out, and we're going to see this pattern that emerges. It's going to help us to factor later on. So when we multiply these conjugates, if we multiply x times x, we get x squared. If we multiply x times 3, we get plus 3x. And then negative 3 times x is going to be negative 3x. And negative 3 times positive 3 is going to be negative 9. And look what happens. These middle terms just cancel out. We have plus 3 minus 3. The middle terms just go away, and we're left with x squared minus 9. Let's see if a similar pattern happens with our other conjugate here. So let's multiply 3 by 3. We know that's going to give us 9. Then we have 3 times negative 2. It's going to be negative 6x. And then 2 times 3 is going to be plus 6x. And then we have 2 times negative 2 is going to be negative 4x squared. So as we can see, in the middle, we got negative 6 plus 6. Those are just going to cancel out. And we are left with 9 minus 4x squared. So let's really figure out if we can understand what the pattern is. So far what we know is when we're multiplying these conjugate factors where they're like opposites of each other, there's no middle term. So when we multiply them out, the middle term went away, and we're just left with the first term squared and the second term squared, and then a minus sign in the middle. And let's take a look at this guy here. Again, the middle terms go away with these conjugates, so these opposite factors. And our result is the first term squared and the second term squared, and again a minus in between. And that makes sense why there has to be a minus in between, because we have negative 3 times positive 3 and positive 2 times negative 2. One of these has to be negative, one of them has to be positive, so it's going to combine to make a negative. So if we were going to go backwards, that means we can recognize when it's going to be these opposite terms or these conjugate terms when we see a squared number minus another squared number. Again, a squared number, or a squared term I should say, minus another squared term. So let's try factoring this guy here, just knowing what we already know about factoring, which we know common factoring, we know decomposition and sum and product. So it says solve each equation by factoring first. So first I'm going to check if there's a common factor. There isn't. Can I use decomposition? Well, we're missing a middle term. So there's an x squared and we don't have an x. But what if I rewrite it? So what if we rewrite it as x squared plus 0x minus 25? Can we use decomposition now? Yes, we can. And we can also use a shortcut, sum and product, because the a value is equal to 1. So because our a value is equal to 1, we can use our shortcut, which is sum and product. So we're looking for two numbers that multiply to 1 times negative 25, and that's so multiplies to negative 25 and adds to the middle number, which is 0. So what two numbers multiply to negative 25 and add to 0? Well, how about 5 and negative 5? So we can rewrite this using sum and product, or shortcut, as a binomial with x, and our two factors, plus 5 and minus 5. And now taking a look at this, there's nothing wrong with doing it this way. There's absolutely nothing wrong, but we're always looking for shortcuts if we can. And taking a look at this example versus the examples we were just working on, we have one of those conjugate examples where we have two opposite factors, and when you multiply them, we got this. So can we start to recognize when the answer is going to be these two conjugate factors. So can we start to recognize when we have a squared term minus another squared term, it's going to look like this, just like it did here and just like it did here, squared term minus another squared term. So now that we realize there's probably a faster way to factor things that look like this, other than by doing decomposition or by sum and product, let's come up with some like tips or rules to help us recognize when we can factor something like this. So when an expression is made up of two squared terms that are subtracting from each other, so because there's only two squared terms, the middle term is missing, and the middle term is missing because it was expanded from something that looked like that. So if there's two square terms that are subtracted from one another, we can factor by difference of squares. So the question is, how can we get right from here right to here? Well, if you take a look at what these numbers are in here, they're just the square roots of the original terms in our original equation. So x is just the square root of x squared, and 5 is just the square root of 25. So if we were to square root these two and put one of them adding and one of them subtracting, then we're done. So here are some steps if you want to formalize it. Ensure that there are two terms. It's a binomial. Each term is a monomial squared, and the terms are subtracting from each other. It's not going to work if they're adding. Find the square root of each term and then rewrite them like this. So I'm going to do it in a different color. I'm going to redo this question really quickly. So if I recognize right away this is a difference of squares, this is a difference two squared numbers, I can immediately just take the square root of each of them. So I would just take the square root of x squared, and I know that that's just x. And I would take the square root of 25, and that's just 5. And then I could just rewrite it as the two terms. So I'm going to write the first square root first, x and x, and then the second square root next, 5 and 5, and one of them should have a plus in front and one of them should have a minus. And because these are conjugates, we know the middle term is going to disappear. We're just going to be left with x squared minus 25, and we're done. So let's see if we can start to recognize some more. Let's take a look at this guy here. So we have two terms, nothing in common, so we can't common factor anything. 144 is a squared term, that's just 12 squared, and m is a squared term, that's just m squared, which means that this is a difference of squares. We could write this out like this. We could write it out like 144 plus 0m minus m squared, and rearrange this so that the m squared is first, and we factor in a -1 and use sum and product or decomposition. But there's a much faster way, because this is a special case where we have two squared terms and subtraction in between it, which means that this is a difference of squares. So our shortcut is just to take the square root of both of these and write two conjugate binomials. So let's take the square root. So we know the square root of 144 is 12. And the square root of m squared is m. And let's just make conjugate binomials with both of these. So we're going to start our binomials blank. We have to put the 12 first because we need 12 times 12 to make positive 144. So don't flip these. So I'm going to put the 12 first, the m second, and then a plus and a minus. And if we expand this, let's do it in our head really fast. 12 times 12 is 144. 12 times negative m is negative 12m. Then we have m times 12 plus 12m. So we have negative 12m plus 12m cancels out. And I have m times negative n makes negative m squared. Let's try this next guy. First of all, anything to common factor? No. So let's keep moving. I do notice that this is a square term, this is a square term, but there's a plus in front of it. Can we still use difference of squares? Well, let's check. Let's try our shortcut of taking the square root. If I take the square root of x squared, I get x. And if I take the square root of 36, I get 6. So if we were to write this out like this, x plus 6 and x minus 6, let's see if it work out. So let's multiply it in our head. Or well, actually, let's multiply it out like this. We have 0 equals x times x, we know is going to be x squared, Then we have x times negative 6x is negative 6x. 6 times x is plus 6x. Those are going to cancel out. Negative 6 plus 6 is going to cancel out. And our last term is going to be plus 6 times negative 6. So we will have negative 36. Is this what we started with? No, we started with this one, which means these are not equivalent. These two are equal, this is not equal. So we cannot use, this is not an answer, we cannot use difference of squares technique if there's a plus in front. Because remember, a conjugate, one of them is positive, one of them is negative. Positive times a negative makes a negative. So this actually cannot be factored. So remember, when using that shortcut, two squared terms, but there's got to be a minus in between. So let's try factoring these weirder looking expressions. This one says no solving, just factor, even though I realized we forgot to solve above. So just go back and solve the previous ones. Okay, so this one just says factors, no equal sign. So these are just expressions. So let's try to recognize this. This looks odd. We've got two terms. We could put a zero term in between and use decomposition, but there's a cool pattern here, which is this is a squared term, 25 n squared. If we were to square root that, we would just get, so square root 25n squared, we would just get 5n. And the next guy is also a squared term. So if we were to square root it, 169m squared would get 13m. Now we can only use our difference of squares trick if there's a minus sign in between, and there's a minus sign. So that means that we can just rewrite this as two monomials, conjugate. So we have two binomials. And we're going to write our first root first, so 5n, and then our second root next. And then one of the binomials has a plus sign and one of them has a minus. Because these are conjugates, the middle term will cancel out and we'll just be left with the square root of the first term, the square root of the second, and a minus in between. Before we get started on this next example, just scratch out this one here. We don't want this one. Okay, so this should say 100x squared minus 49y squared. So now that you're familiar with all of the factoring techniques, decomposition, difference of squares, common factoring, try this guy on your own and come back to the video once you've got it factored. Okay, if you're back at the video, you've tried this on your own. Hopefully you realize this is another difference of squares. This is a square term, this is a square term, a minus in the middle. That means the middle term is gone, and it's only going to be gone and cancel out if it factors as a conjugate. So if we square root the first guy, we get 10x. If we square root the second guy, we get 7y. So we're going to create a conjugate with these two monomials. We've got 10x plus 7y and 10x minus 7y, and we're done. Remember these last questions, we weren't asked to solve. This is just a factoring exercise, okay? So here we've come to our last example. So taking a look at this is, first off, I've got two terms. So I know I could use decomposition if I put a zero term in the middle, perhaps. Taking a look at these two, this is not a squared number, this is not a squared term. However, we cannot forget the first type of factoring we learned, which is always the type of factoring we need to start with, which is common factoring. Do these two have something in common? Well, they do. It's 3. So before you start anything, take out that 3 and something beautiful might happen. So I'll be left with x squared minus 27 divided by 3 is 9. And now take a look in here. We have a difference of two squared numbers, which means that we can use our shortcut of difference of squares. So square rooting the first guy would give us x, square rooting the second guy would give us 3, and we can make our conjugate of x plus 3 and x minus 3. And we're done.